In this section, we are going to be looking at some questions that I like to call liquid to liquid. We're going to be using the mole plan, and they have a special name called titration because they're happening between an acid and a base. So what's going to be given in this question is, with respect to, say, the acid, we're going to be given a known concentration of the acid and a known volume, so C and a V. And from there, we're going to be given a known volume of a base, and we're going to be asked to figure out its unknown concentration. Now, consider that we do have a couple of C's and a couple of V's. We are not doing a dilution. This is not a C1V1 equals C2V2 question. This is not a dilution question because dilution questions involve one substance and you adding a bunch of water. So if you start with an acid, you add a bunch of water, you still have an acid. So you'll notice in this question, we're talking about an acid and a base. So to accomplish this, no dilution formula, what we're going to be using is our mole plan. So our first step is we're going to be finding the moles of one of the compounds, and you will be given a concentration and a volume. So that will allow you to find moles of one of the two substances. Then in step 2, you'll find the moles of the other substance using a mole ratio. And then lastly, you're going to answer the question. So there's sort of two possible questions that could be asked. Firstly, you could be asked to find the concentration of the other compound, or you could be asked to find the volume of the other compound. It all varies on the type of question. So in essence, though, we will be doing the same 3 steps all the time. You'll be finding the moles using that formula. You'll be using a mole ratio in step 2. And then step 3 will be either one of these particular formulas. So let's take a look at a question here. So what volume of 0.25 molar sulfuric acid, H2SO4, is needed to react completely with 37 mils of 0.65 molar potassium hydroxide? So even before we get started this question, we know we're going to need to do a mole ratio, meaning we know we're going to need a balanced equation. So we're going to have to create a balanced equation, which is going to be our sulfuric acid plus our potassium hydroxide. Now, I should also point out something here, that this is an acid reacting with a base, and you'll remember from earlier in the course that acid plus base is a neutralization reaction, which creates water, H2O, and some kind of salt or ionic compound. And in this case, the salt ionic compound is coming from potassium and sulfate coming together, making potassium sulfate. I did a little crossover there. We're not quite finished because we need to do some balancing. You should notice that there are 2 potassiums, so we'll put a 2 in front of potassium hydroxide. And then if you were to count up all the hydrogens, we have 2 hydrogens here and another 2 hydrogens there, giving us 4 hydrogens on the left. So if we put a 2 here, that should give us 4 hydrogens on the right side. And now, when we have a balanced equation, we can proceed with our question. So there's our question again, and you'll notice that we've got a volume and a concentration with respect to the potassium hydroxide. So that's going to be our first step. We're going to find the moles of the potassium hydroxide. So N equals C times V. We can pull the C right out of the question. There is our concentration. And then we've got our volume. Now, we do have to remember that we don't want to work in milliliters with this sort of stuff. So to come up with liters, we're simply going to divide 37.2 by 1,000. It gives us that particular value. And so that is going to act as our volume. So if you have your calculator and you do a quick calculation, those two numbers together should give us our moles of potassium hydroxide, and that is step 1. So if we have the moles of potassium hydroxide in step 1, that means step 2, we're going to be finding the moles of the other compound, which is sulfuric acid in this case. So all we've done is I've carried that number forward. Don't clear your calculators. All we need to do is simply write out our mole ratio. And so we've got a 2 on the bottom and a 1 on the top. And of course, these are multiplied together. So we're going to cancel the moles of calcium hydroxide with the moles of potassium hydroxide. And so it looks like our values there multiplied by 1 divided by 2 give us 0.01209 moles of sulfuric acid. We're just about done here. So step 3. Again, a quick look at the question says we want to find our volume of this particular compound. So there's our volume formula rearranged, and we just found the N in the last step, and our concentration is right there in the question. So let's plug our 2 numbers in, and when you divide, you get 0.4836 liters, or 483.3 milliliters. We probably don't need to do that. We'll just keep our answer in liters. So what exactly is a titration? Why did I call it titration, and how would it apply to this particular type of question? Well, again, remember, it's titrations can only happen between acids and bases when there's some neutralization going on. So if we were going to carry this out in the lab, our first step would be to grab a pipette and have an acidic solution perhaps present. You could start with a base. In this example, we'll just start with an acid. Now, we're going to know our volume of acid because perhaps we grabbed a 10 ml pipette, so you know you've got 10 mLs of acid. And what we don't know is we don't know the concentration of this acid. We're going to work through our problem to figure that out. Step 2, you're going to grab an indicator, and most likely it's going to be phenolphthalein, and you're going to put a few drops into your solution, and the acid, I know in this picture, is blue, but in reality it will be colorless, and when you put in a few drops of the phenolphthalein, it will remain colorless. Then you're going to grab, in step 3, a burette and fill it up with some base. And what we'll know about the base is we'll know the concentration of the base. That should be given. And through the experiment, we're actually going to be able to figure out how much of it we're going to put in. So in step 4, what you're going to do is you are going to open the device and you're going to start to pour in some base and swirl it around. And what's going to happen is you're going to end up coming to a point where you see a color change. So it will go from being colorless to be going pink. And once it's gone pink, you need to stop. And then we can, of course, read off our burette reading. So if we started there and you ended there, you could figure out your volume. So your volume, you'll have a known volume of base. And the solution has reached the endpoint and is now slightly basic. That's why it's pink. So just a quick summary here. The experiment must be carried out a number of times until you get several similar results or trials. Everything should be, you're using the same acid and base, you should get the same numbers. If you did a trial where you got 25 and then you did another one, you got 27, you got a problem on your hands. You're going to need to do at least a third and maybe fourth one to get a consistent number. Once we're done all this, let's just review what we know. We've got a known volume of base from the burette, and the concentration should be given. And the other thing you'll know is the initial volume of the acid because you pipetted that in. And of course, given these 3 pieces of information, you can go through our mole plan to figure out the unknown concentration of the acid. And keep in mind, we could have flipped around this question as well. We could have put the base using our pipette into our flask and filled up the burette with acid, and it still would work the exact same way.